Hey YouTube, Stefan here from Be a Python Dev. We are doing the merge to list problem on Leet Code. I literally just did this, but the video is unusable. So as you can see, a few seconds ago, answer was accepted. Cool stuff. We're gonna rework through this. First, when you're working through these kind of problems, you want to think through what kind of use cases can break your problem. One of them is going to be, what if these lists are none? So if L1 equals none, return L2. If L2 is none, return L1. So this will actually cover the case if both of these are none, because if L1 is none, we're going to return the L2 head node, and that'll just be none, and that will cover the criteria in the description to merge the two sorted lists. The next thing we want to do is iterate through both of the loops while something exists, and kind of finding which one the smallest one is, the smallest value node, and then adding that into our head and current pointers. The head is just going to be the front of the list that we end up creating, and it is going to be what we return. The current pointer is going to be tracking where we are on the list so that we can add new nodes to it as we traverse through the problem. So while we have an L1 and an L2, if L1.val is less than or equal to L2.val, we're going to need temp node. So we're going to be setting this temp node based on this logic statement here. Temp node equals L1, else temp node equals L2. And then we do have kind of two different criteria when we're setting our things. If our head node hasn't been set, we're going to want to set the head node. Else we're going to want to append new values. Also in this, we need to set our L1 pointer to the next L1 value so that we can like keep moving along as we go through. So L1 equals L1.next. So if we're adding L1 into our temp node chain, we set L1 pointer to the next value. And same with L2 here. L2 equals L2.next. All right, so if our head node equals none, we're gonna set it. So head equals temp node, cur equals temp node. I think that's all we need to do. Can't remember, we don't have an X value yet. All right, else cur.next equals temp node, cur equals cur.next. I think this was right. And then we're going to return our head node. So originally this video took me 12 minutes where I had to like debug some cases, and it was fun because you get to see the debugging process and kind of thinking through how to work through problems. I don't know if this is going to happen here. Let's go ahead and see. So this test case kind of is boring. Let's populate a test case here just so we can see. And let's throw in some weird values where we mix it up a little bit. 10, 12, all right. And we run this. Judging. Hey, wrong answer. 1, 1, 2, 4, 7, 8. Oh yeah, that was okay. I forgot. All right, so when we're going through L1 and L2, we got to this case where we added in 1, 2, 7, and 8, and then our 8 value ended. Like there was no other values in the list. So what we need to do is we need to add the rest of the L1 list that we haven't walked through yet, which would be the 10 and the 12. So we need to go ahead and do that here. If L1, see, I talked too soon. I did end up breaking things, and I did have to think through what was going on. So if our L1 pointer is empty, then that means we reached the end of that. And then we want our current dot next to equal the whatever is left in L2. And then let's fix our spacing here. And then same situation here. If L1 is empty, well, if L2 is empty, that's what we're here. We want to add in the next values in L1. So this should add 10 and 12 into our output. All right, so that's accepted. We'll go ahead and run it through the whole suite of test cases. A lot of times they throw in some weird funky stuff at you, especially if you're doing like recursive problems where you end up timing out because they're looking for some memoized dynamic programming solution. We'll get into that in the future. I am horrible at those problems, so we'll get to see me struggle through those. But that's the whole point here, is to progressively get better. I don't do Leet Code a whole lot, but it's a great way to improve your algorithm coding ability and make you more confident when you're coding, and that actually translates to gains when you're doing something on the job. So that's kind of what we're trying to accomplish here, and get better at teaching through problems at the same time. So we'll submit this. Okay. So same runtime, same memory as we got from the last one that we worked through. If you like these kind of problems, like, subscribe, comment, all that fun stuff. And if you want to learn more about career development in Python, head over to the blog beapython.dev in the description below. See ya.